What do all three of these equations have in common? What is it about all three of these that they're more or less the same type of equation? In each of these equations, we have more than one variable. At least the variable we have is in more than one place. So like the first one, we have an x here and we have an x here. Second one, we have a y here and we have a y here. Last one, we have a z here and we have a z here. So the variable's in different places. We're going to have to get it by itself. But to get it by itself, it can't be in different places. So we're going to have to do what we were doing a couple weeks ago and get the variable in one place before we can get it by itself. Alright, so starting with that first equation with the x, what do I need to do first when I'm solving this equation? We'll start with circling the variable. We see when we do that we have x's in two different places. We draw a line of equality, and that's it. There's no boxes to draw. There's no square or square root, so that's all we have to do. So now our goal is to get the x in one place. So can I just combine like terms right now? Combine the 3x and the 2x?
Yeah.
No. Why can I not combine them yet?
The 3x is in parentheses.
Exactly. The 3x is in parentheses. So this parentheses here needs to be taken care of before I can start combining. So what do I do first? Using the distributive property, what are we going to get? Negative 2 times 3x is? Negative 6x. Negative 2 times negative 5 is? Positive 10. Make sure you get a positive there because a negative times a negative is a positive. Should I distribute the negative 2 times 2x also?
No.
No. That's not in the parentheses, so we're not going to distribute that. So what do we do with it?
Bring it down.
Just bring it down. So plus 2x there, equal sign on the line of equality, and equals 6 over here. All right. After we distribute, then we can combine like terms. So we have like terms here, the negative 6x and the 2x. When we combine those, what do we get? Negative 4x. And can I combine these other like terms, the 10 and the negative 6? No, why not? They're on different sides of the equal sign. Since they're on different sides of the equal sign, we cannot combine those. So what do we do with them? Bring them down. So bring down the plus 10 on the left, bring down the negative 6 on the right, equal sign on the line of equality. Now what? Okay, now we need to get rid of the plus 10. We'll do that by subtracting 10. So minus 10 on each side. On the left side, the plus 10 and the minus 10 cancel each other out. That leaves the negative 4x. And on the right side, negative 6 minus 10 is negative 16. Alright, now we need to get rid of that negative 4, so are we going to add 4? No, we need to divide. We need to divide because it is, what is this? Negative 4x means negative 4 times x. So get rid of the multiplication, we divide. Make sure you divide by the number you're trying to get rid of, which is a negative 4. And when the negative 4 is canceled, that leaves x equals positive or negative? Positive, because when we do a negative divided by a negative, it gives us a positive. Alright, so we're always going to start by circling the variable, draw the line of equality, so I'll do that first. Circle the y's, draw the line through the equal sign, and I need to get the y's in one place. Again, they're in two different places. Can I combine like terms yet? No, we first need to get rid of the parentheses. So to get rid of the parentheses, we're going to distribute that negative 1. Negative 1 times y is negative y, or negative 1y. I'll keep the 1 on there for now. And negative 1 times 10 is negative 10. All that other stuff that doesn't distribute, what do we do? Bring it down. So we've got 11 on the left side, equal sign on the line of equality, and 4y on the right side. And now we're going to combine our like terms. So we've got our 4y minus 1y is 3y. Nothing else can combine, so we'll just bring everything else down. So we've got the minus 10 and the 11. Then what? Add 10 to both sides. So we get 3y on the right, and what do we have on the left? 21. And then what?
3.
Divide by 3. So we divide by 3 on each side. 3's cancel on the right, leaving y all by itself. And on the left side, 21 divided by 3 is?
7.
So we get 7 equals y. Alright, so I mentioned with this one when we got started, this one is different. We've never solved an equation like this before, but it looks pretty similar. What is different about this one?
The variables on the different sides.
Yeah, so here the variables on different sides. So after we distribute, we cannot combine like terms to get the variable in one place because it's going to be on different sides. So we'll start by doing the same thing we did first last time. We'll distribute. 4 times z is
4z.
4z, and 4 times negative 3 is negative 12. Okay, so that's what we get on the left side. On the right side we distribute the 2. 2 times z is
2z.
2z. And 2 times 3 is 6. That's a positive 6, right?
Yes.
Okay, and then we bring down everything else, so equal sign on the line, and then plus 4. And now, if we wanted to get the z in one place, we would have trouble with that, right? We can't just combine them. We can't combine the 4z and the 2z because they're on different sides. So we're going to have to do something else to get the z's in one place. Before we do that, though, what is something else that we can do? We distributed, but we can also...
Plus 12.
We can combine like terms here where? The 6 and the 4, right? So the 6 and the 4 are like terms. We can combine those and get 10. So we've got a plus 10 there. So when we simplify each side of the equation, this is what we end up with. We have 4z minus 12 equals 2z plus 10. Again, the z's are in different places, but they're also on different sides of the equal sign, so we can't combine them. Anybody have an idea what we could do here?
Subtract 2z.
Okay, good. So if we want to get the z's in one place and we can't combine them, let's get rid of one of them. So Alejandro wants to get rid of the 2z. I will tell you this. It doesn't matter if we get rid of the 2z here, if we get rid of the 4z here. We will get the same answer if we do the work correctly. There's something that I'm always going to use to decide which one to get rid of, and it's just going to make things easier by working with positive numbers more often. But it doesn't really matter. So if you got rid of the 4z, that's okay. But we're going to get rid of the 2z, and as Alejandro said, we'll do that by subtracting 2z. But if we subtract 2z on the right, we need to subtract 2z on the left. All right. Now notice that when I did this, I didn't subtract from the 12 and the 10, but I subtracted from the 2z and the 4z. Why did I do that?
Because
They're like terms, exactly. So when we're subtracting it from the whole thing, but when we actually do the subtraction, we can only do it with like terms. So we're going to subtract it from the 4z. So on the right side, those 2z's cancel, leaving what? 10. On the left side, we have 4z minus 2z is 2z. And then we have our minus 12 that we're going to bring down. Now what?
No, we add 12.
Yeah, now we just solve like we normally do. So we're going to add 12 on each side. Those 12s are going to cancel, leaving 2z. And on the right side, 10 plus 12 is 22. And then
We divide by 2.
divide by 2. And when those 2's cancel on the left, we get z over there. And then 22 divided by 2 is
11.
11.